Okay, this is the third time at my attempt to make this video. The first two times it deleted it, which has been very frustrating because that's a lot of time wasted. And in this new program I'm using, I cannot see the preview screen. So if you see me in the bottom left-hand corner of the screen, I can't see myself, which is kind of weird. So hopefully this works out. I'm out today, but that doesn't mean you can't learn anything. So we're just going to go over the basics of the sun, earth, and moon. Your interactive notebook should be open. I'll post this in Edpuzzle as well. Or I'm sorry, your interactive notebook should be open, and you're just going to kind of follow along and take some notes. And feel free to pause it at any time and take notes on the website as well. And then you'll have a quick check at the end on Schoology. So the first thing I did was I tried to find a funny meme that was silly on astronomy, and a lot of them were not school appropriate. And so I'm not going to Google those right now. But there was a couple clever ones. Like, how do you organize a party of the solar system? You have to plan it. I know, you're cracking up right now. Get it? Plan it. All right, moving on. So in Classroom, you'll see a link, and the link will take you to spacefacts.com. And I'm just going to go through some of the most important things that I think you should know between the sun, earth, and moon. On Monday and Tuesday, we'll get started kind of learning about these and how these work together. But these three items in our solar system essentially cause every major phenomenon on Earth to happen. It's because of these three things working together in the system. So let's just start with our home planet. Click on the right-hand side. Click on Earth. All right, so here's our Earth. Notice right away, it looks different than most planets because there's blue on it. That's liquid water. And so far, we have not found liquid water. Debate about Mars, but we haven't found liquid water anywhere like we have on Earth. Let's go over some key facts. Okay, it's the third planet from the sun. That's really important to know. Some important facts right here. Orbit. So the word orbit, if you haven't figured it out, you can Google it, but orbit means its ability to go around something. So if the moon is to orbit something, it's orbiting the sun, okay? And it takes 365 days roughly to orbit the sun. That's a year, okay? If it orbits the sun one time, that's a year. Obviously, it rotates as well, but orbit and revolve are synonyms, and it means to go around the sun. We have one moon, also known as one natural satellite, and that also orbits us, and we'll talk about that in a minute. So those are some cool things. Look at our surface temperature. Big range here. Obviously, different parts of the Earth receive heat differently, and we can either be hot, and it was like 87 this week, and it can be cold, and it was 33 2 weeks ago. Here's a good picture. This is the moon. This is the Earth. Notice how much larger the Earth is than the moon. It's a difference of 1/4, meaning the moon is 1/4 the size of the Earth. The moon is 1/4 the size, and it's 1/6 the gravity. So the Earth is not huge, but it's much bigger than our moon. Some interesting facts. The Earth's rotation is gradually slowing. Not anything major, but it is gradually slowing. You can read for yourself on this website. It was once believed to be the center of the universe. So let's break down the two different things here. One of those things is called geocentric, and that is when people before the 1500s believed that the Earth was the center. And we talked about how the Catholic Church wanted that to be true because it felt like it was most important. But a guy by the name of Copernicus and Galileo kind of disproved that. And now we believe in a heliocentric model that the sun is the center. So geocentric, no more. Has a magnetic field, which actually is like our protective shield, meaning the sun's rays and wind, that solar wind that could really hurt us. The magnetic field kind of blocks that. And we have only one natural satellite, being the moon. Obviously, we have a ton of satellites above our head, but a natural satellite is one that we didn't put up, and that's our moon. And it's also the densest planet in our solar system for its core. And that's our Earth. That's what you have to know. Let's go to the moon. All right, the moon, or Luna, as we call it, as we said, is the Earth's only natural satellite. And this is really important here, and I'll kind of highlight the sentence. The moon is in synchronous rotation with Earth's, meaning the same side is always facing Earth. If you could copy that sentence in your notebooks, that'd be phenomenal. I'll break it down again. The moon rotates at the same speed as it revolves. One more time. The moon rotates at the same speed at which it revolves. I can explain that more next week, but pretty much it'd be like you facing a tree and your friends on the other side of the tree. Imagine that you could not see each other because on the other side of the tree, and you both walked in a circle, continually not seeing each other, facing each other, but not seeing each other. You're walking around the tree, you're revolving at the same rate as you're rotating. If that is confusing to you, I can promise you I can help make sense when I get back, but pretty much As it spins, it also moves around in a circle at the exact same rate. Pretty interesting stuff. Another important thing is that it's not on here, but it's about a quarter of a million miles away from Earth, meaning it's about 200 and roughly, it depends what time of year, 200, let's say 25,000 miles, 100,000 miles away from Earth, 225,000, 100,000 miles away from Earth. So it's pretty far away. Our astronauts took 3 days to get there in 1969. So 3 days just to get there. Again, here's the word orbit. How fast does it go around something or revolve? It takes about a month. This exact number you probably should know is 27.3 days. 27.3 days. All right, so here's a comparison chart again. Some more facts. The dark side of the moon is a myth. Well, it's kind of a myth. The sun shines on it all the time, but it's dark to us. So let's read this last sentence. The side facing away from Earth has only been seen by a human eye from spacecraft. Here's what I mean. If this right here is the moon, this gray dot, I will only see this side. But as you know, in a basketball or any kind of ball, there's another side. I have an orange right here, right? You can see, let me write on it real quick. You can see the side with the D on it, right? See that side? The side that I see, though, that has never been seen by a human from Earth. We only ever see this side because the moon always faces this side towards Earth, being you right there looking at me. A spacecraft could fly around this orange essentially and see this side. We can take pictures of it, which we have, but we only ever see at nighttime this side. So when you look up at the moon tonight, you've seen the same side of the moon every night for the rest of your life. The rise and the fall of tides are caused by the moon. The moon is drifting away from Earth. A person would weigh much less on the moon, meaning if I was to go to the moon tonight, I would lose about 1/6 of my weight. I did the math. I'm about 190 pounds. If I divided that by 6, I'm about 32 pounds. So if I went to the moon, I'd be 32 pounds. I wouldn't look any thinner. I wouldn't lose actual weight. Or lose mass. I would just lose weight because the gravity is so less. It's 1/6 the amount of gravity, meaning I'm not being pushed down on the planet as much as I am being pushed down here on Earth. We can talk more about that too. The moon has only been walked on by 12 people, and they were all American males. We have not visited there since 1972, and the last person to go was Gene Cernan. He's actually just passed away last month. The moon has no atmosphere. That's why it's very cold and very hot, and there's no sound that can be heard, and the sky always appears black. What else is important? Look at this. The first spacecraft to reach the moon was from Russia in 1959, but we were the only country to ever walk upon the moon. And that's pretty much it. If you want to copy this down in your notes, the phases of the moon, this is really important. We're going to get into this heavily in the next 2 weeks. But do you understand the moon goes through phases throughout the month is really important. A new moon, you can't see the moon at all. And a full moon, you can see the whole thing. And it goes through steps in between. Let's move on to the sun. Okay, so here's our sun. Our sun is huge compared to the moon and compared to Earth. It is massive, also known as the Sol. It is a medium-sized star. However, it is our only star in the solar system. It's one of millions and billions upon our galaxy, but for our solar system, it is the only one. So the sun can be really hot at 5,500 degrees Celsius, which is super hot. Notice the chart here. This is actual to scale, I guess you would say. There's the sun, Earth. Here's Jupiter. Jupiter is the biggest planet in our solar system. Look how much bigger the sun is than Jupiter. Let's do some size comparisons for a moment. If I were to take Earths and to throw them into the sun, if I could do that, like M&Ms in a jar, I could fit 1 million Earths inside there. If I were to take Earths and line them up across a diameter, I could fit 109 of them across a diameter. That's how big our sun is. It heats up the entire solar system, causes light, causes life, and it is pretty big compared to us. Here's some interesting facts. The sun is all the colors mixed together. This appears white to our eyes. It's mostly made up of hydrogen and helium. Those two things work together by something called nuclear fusion on the sun. It's a main sequence star, which means it's kind of an average star, but it seems huge to us. And like I said, it's really big, 109 times wider than us. You could fit 1 million Earths inside, we said. This is crazy. It contains over 99% of the mass in our solar system. Eventually, the sun will consume Earth, and we'll talk more about a life of a star. But if the sun were to start dying, it actually would expand